And this is going to be 7, 2, the alpha lesson. Now, the difference between 7, 2, and 7, 3. Now, listen to this. All the problems we do today will be dx. The problems we do in the beta lesson will be dy. So here's this picture. How can we find the area between these two curves? You want what area is encaptured there. Okay? And what you notice is it's an artificial question because the two curves meet very conveniently. So if you're at home, you can't see what we're going to do, but I'm going to take y1, which is 2 plus a negative x squared, and set it equal to y2, which is a negative x. And if we set them equal to each other, that's where they would meet. Is that logical? So I would say, okay, let's add x squared and negative 2 to both sides, and you would get x squared plus a negative x plus a negative 2, and that would be 0. And that is a quadratic. So it's degree 2. So how many zeros does it have, McGarrigle? Thank you. And how many are real? Thank you. Exactly. That's the fundamental theorem of algebra. So we go over here, we build a lattice. And our lattice would look like this. X squared and a negative 2. So what multiplies to x squared? X times x. What multiplies to negative 2? 2 times 1, where one of them is negative. But the sum of the two terms in the middle is negative 2. There's negative 1x, sorry. So this has to be the negative, which would give you negative 2x and a positive x, and they would add to negative x. So the linear factors are x plus a negative 2, x plus 1, and their product is 0. So what makes this 0? 2, well, negative 1, and 2 make the product 0. So both of these graphs have to meet there. So they have to have the same height. So the easier graph to deal with is negative x. So the opposite of this is 1. The opposite of that's a negative 2. Those have to be the points of intersection. So what are we going to do? We're going to do the sum of all the little rectangles that are what? This tall, this dx wide, from negative 1 to positive 2. Now, before I go on, you need to just think for a moment if that seems logical. Because from my perspective, I can think of very few things that are more logical than that. So, moving forward, there is your visual representation of dx. It's a very thin vertical strip. And what are we going to do? The strip is how tall, the length, which is essentially the height of this strip, is there to there. Y1 take away Y2. It is upper take away lower. So we would say this take away that. Now think about this. How tall is this curve? Well, it's ready. That's your output. 2 take away x squared. So if I went here where the strip seems to be at a 1, then this height would be a 1. 2 take away 1 squared would be a 1. I guess it's a half there, right? That's the notch is at a half. So I put 1/2 in there. And 1/2 squared is 1/4. So 2 take away 1/4. This is 1 3/4 tall. Because why? It's that take away 0. And then I say, how tall is this one? Well, it's below the axis. It's 0 take away negative 1/2. And what are you doing? You're saying, instead of doing it twice, you're just saying, what's y1 take away y2? That's the height of that strip. So dx is an instantaneous change. It's like imagining that thing is like less than the width of a hair. But if we draw the picture just to help us see what's going on, it's fine. And what are we going to do with it? We're going to multiply it by how wide it is. So it is this tall. They use length. I'm saying height. 2 take away x squared plus x, because you subtracted a negative. This strip is that tall, and it's dx wide. So if you add them all up, that's what integration is doing. It's saying, add up sum, S for sum, all the rectangles, all the thin strips that are this tall and that wide, from left to right, starting at -1 and ending at +2, which is just doing the power rule in reverse, moving forward. Which I get. The power rule in reverse was confusing for probably 2 or 3 days. You have to be over that by now. So here it is. This is 2x to the 0. And you replace that exponent of 0 with 0 plus 1, and you divide by 1. And that's how 2 goes to 2x. And they all go the same way, power rule in reverse. Put 2 in there for x. Subtract, put -1 in there for x. And you get 9/2. What does that mean? The area between the curves is 4.5 units squared. And they say this is the area between curves. You don't memorize it, you just think through it. But you got to listen to this. It's upper take away lower. If you're doing the problem dx, and that really distinction might not make sense to you until tomorrow when we do some problems dy. But if you're doing the problem dx, your thin strip is perpendicular to the x-axis. And if it's perpendicular, we do upper take away lower, starting at the left intersection to the right intersection for the input values. This problem is a little different. Why is this problem a little different? No, it's the same. We still got to find out where they meet, yes? So I say, okay, find out where they meet. I would have this. Because they only meet once. They meet at the right. So root x equals x plus a negative 2. You want to find out when they're the same. So suppose we square both sides. We would get x equals x squared plus a negative 4x plus 4. Yes? So we would have x squared plus a negative 5x plus 4. Here is our lattice. So we got 4 and 1, where they're both negative. So it's going to meet at 1 and 4. Is that right? One to the right. Well, one to the right, they don't meet. 4 to the right. 4 to the right, they meet. Okay? Why don't they meet at 1 to the right? Why not? Yeah, because we're only in the first quadrant. If we had both roots, if we had negative root x, yes, then it would come down here and look like this. And then they would meet at 1 to the right. Because what happened? When we squared this thing, we got x. If it was the opposite of this and we squared it, we'd still get x. But we're only looking at the first quadrant. So now the limits, ready? The only thing we're sure about is the last limit being a 4. But why can't we just do upper take away lower here? Correct, because it would include what's below, what's in quadrant 4. See, here, from here to here, upper take away lower is the curve take away the axis. Beginning at 2, upper take away lower is the curve take away the line. You need to be focused when you're doing these problems. Like the people that sleepwalk through the questions, oh, I know how to do this. Upper take away lower, I can hear your voice in my head. But it's two separate areas here. So here's how they do it. So they went from 0 to 2. Where did they get the 2? It's a mystery. Where's the 2 come from? Seriously? It's where the line hits the curve. I'm sorry, not the line hits the curve. It's where the line hits the axis. When x is 2, it's hitting the x-axis. So you're going from 0 to 2 for this part, and from 2 to 4 for that part. But on the left side, now this is easy. I think it's easier to see in your book. In the book, they have it shaded. Like they got this colored in. But anyway, you got 2 separate areas to calculate. I have it on the PDF, so we'll get to that. Now, we're not doing D1. All right. So we're going to stop there. And we're going to go here to the PDF. Now, before we before we go to the PDF, let's just read this question. This is problem 52 at the end of the section. And they're not giving you a picture. They're asking you to think about this. Let R be the region, the first quadrant, bounded by the x-axis in the graph, x equals y squared plus 2. And the line x equals 4. Which of the following integrals gives you the area of R? Do you recognize what a mess that is? Y depends upon x. You can't answer that yet. We can't answer that question today. But you have to think about this. Like, oh, that's where I'm going to go in the beta lesson? That looks like a mess. I better get on board with the alpha lesson now before I'm held accountable to do that problem. So here is where we left off on the PowerPoint. So I'll bring up the picture in the book. There's the picture of the book. Okay, so it's easier to see what's going on here because they made the first area is gray and the second area is blue. They call them A and B. But that's what we're doing. So if you look in the textbook, area A is root x, except it's not. It's really upper take away lower, which is root x take away 0. The difference of the y's. Yeah, but I can't tell there's a 0 there. It doesn't matter. It's helpful to write subtract 0 because then you can see consistently what's happening as you move on. Then the gray one is root x take away the line. Upper take away lower. So in order to make this consistent, when we get to the PDF, I wrote A as root x take away 0, which isn't going to affect your calculation, but it's going to make how you set the problem up more consistent. So I've got root x take away 0. What is that? That's the height. Dx is the width. And I want to add up all those thin vertical strips from 0 to 2. The other one is add this area, the blue area shaded in, from 2 to 4. Root x take away the line. Careful, you're taking away a negative. You're distributing a negative over that. So here, this line right here, power rule in reverse. Root x is x to the 1/2 power. Add 1, 3/2, divide by 3/2, same as multiplying by 2/3. Derivative of 0 is 0. Plus the constant. Same thing here because you have root x. X to the first, 1 plus 1 divided by 2. 2x to the 0, x to the first divided by 1, plus the constant. The constants would subtract out. Put 2 in here, put 2 in there, put 0 in here. That gives you 0. Put 0 in here. All right, and it ends up being 10/3. I'm sorry, not put 0 in here, put 2 in here. 4 in here, subtract, put 2 in there, which gives you 10/3, which represents the area there. Now, if it's a non-calculator problem, the calculation can be relatively friendly. And that's a non-calculator question. Okay? So we're going to leave that up there, and you're going to go to problem number 9. This is your model. So the picture would look like this. Y equals x is blue. X squared divided by 4 is red. You want the area of that section in quadrant 1. So we go here. From 0 to 1, we have x take away the curve. From 1 to 2, we have 1 take away the curve because it was actually also this. Sorry. For the picture, it was enclosed by all of them. All right. So in the picture, from 0 to 1, we're going blue take away red. From 1 to 2, we're doing black take away red. Does that make sense? Everybody see that? We'll just zoom out. Zoom in a little bit. So, from 0 to 1, it's blue take away red. From 1 to 2, it's black take away red. Upper take away lower. So you have the sum of those two integrals. This represents the power rule in reverse for blue take away red. This represents the power rule in reverse for black take away red. And you would get to 5/6. 5/6 square units is what that represents. The area of that region in quadrant 1. Now, if we go back to this picture, here's why you need to focus. Because this is 5/6 square units. It's 2 dimensions. But what we get to later in the chapter is making that region 3 dimensions and rotating it. So you have to understand 2 dimensions first. If you're at home, you are dismissed to go do the exit ticket. We will see you in the building tomorrow.